turbocharger is a simple exhaust-driven component designed to increase an engine's power output by way of forced induction. The concept is this: the more oxygen that can be squeezed into an engine's combustion chamber equals more fuel that can be added as well. When ignited, this increase in combustion forces is usually much more than a naturally aspirated engine. The turbocharger is driven by hot gases directed from the exhaust manifold, driving a turbine wheel located in the center section of the turbo, which is coupled with a compressor wheel on the other end. The rotation of the turbine compressor wheel forces air into the intake system. It is essential to understand that the turbocharger requires a flow of exhaust gases and mainly heat from those expanding gases to process and produce the flow. Most original equipment turbocharging systems have a turbocharger, an intercooler, and components that control the boost. The turbocharger consists of 3 sections: a compressor housing, a center section, and a turbine housing. The compressor housing, also known as the cold side, houses a compressor wheel that is attached to the center housing of the intake plenum. The center section consists of a compressor wheel, turbine shaft, turbine wheel bearing, and oil and coolant passages. The center section is also called the bearing housing. Lastly, the turbine housing, known as the hot side, contains the turbine wheel, and most applications have an integrated wastegate. Naturally, air temperature increases when you compress the air. Therefore, an intercooler is used to cool the air discharged from the compressor. This radiator type component can be water to air, much like a radiator, or air to air, where the ambient air passing over the fins cools the air passing through the intercooler. Although forcing more air through the cylinders increases volumetric efficiency of the engine and desirably increases power, it is necessary to control the boost pressure. Since the turbocharger uses heat energy from the exhaust to produce boost, the more boost pressure it produces, the more heat. It is essential that controls are in place to prevent excessive boost, which can cause turbo and engine damage. Conversely, a deficiency in boost pressure will decrease the power output of the engine. Most systems employ a wastegate or a bypass valve to control the system. Wastegates control the boost pressure by redirecting the exhaust gases around the turbine to bypass or maintain flow to the turbo. It uses a diaphragm attached to an actuating rod to open and close the valve. Most OEM wastegates are integrated into the turbo, but some aftermarket applications use a remote design enabled with a larger diaphragm and better materials. The wastegate is controlled by the amount of pressure the turbo is creating. This pressure usually is derived from the intake manifold or compressor discharge. This is called a wastegate actuator signal. The valve opens once the wastegate actuator signal overcomes the diaphragm spring. While the wastegate protects the vehicle from producing too much boost, the bypass and pressure release valve, sometimes known as a blow-off valve or BOV, releases the displaced boost pressure when the throttle is closed. These valves can be vacuum or electric solenoids. While all turbocharger systems are made up of the basic parts just described, each vehicle application can have a different diagnostic strategy to test and confirm proper operation. Make sure you refer to the vehicle's service information before attempting to repair or replace your turbocharger. Thanks for watching. Thank you for watching. Check out Rotomaster.com for more information about our industry-leading turbochargers and how-to technical content.